In this tutorial video, I will talk about the creation and customization of pairwise plot matrices in KIWI Explorer. A pairwise plot matrix is a plot intended to investigate the distribution and co-distributions between multiple variables in a dataset. It is a single panel of plots presented in a matrix fashion, and it integrates scatter plot, bar chart, histograms. So it combines all the functionalities and design of this separate EDA type. In this video, I will talk about how you can select the continuous and categorical variables, which will be displayed on this matrix of plots. I will also talk about the few options that you have access to, including the filtering of the variable by their types, and I will also illustrate the use of various display options. I will now switch to the application. I have open KIWI Explorer and the profile manager for a single dataset called subset_demo.csv. This is a population pharmacokinetic dataset which we have used in previous tutorials. It contains information for many subjects and include many different variables, including many subject characteristics. Let's start this presentation by selecting the global profile. This is the non-editable profile, which contains which is defined with all the settings set to their default value. With this profile, we obtain a single panel or a single image containing a square matrix of plots. The y and the x dimension list the same variables, in this case gender, age, treatment, creatinine clearance, study, and weight. So the same variables are shown in the same order on the x dimension. The plot is organized in a diagonal set of panels, a lower triangle, and an upper triangle sets of panels. The diagonal panels show the distribution of each variable, or summarize the distribution of each variable. For categorical variables like gender, we get a bar chart. For continuous variable like age, we get a histogram. Treatment and studies were categorical, and so we got a histogram, a bar chart. Histograms were generated for the two additional continuous variables, creatinine clearance and weight. In the upper triangle, we have different types of plots. At the intersection of two continuous variables, we have scatter plots. At the intersection of a continuous variable and a categorical variable, we observe a box and whisker plot. So the continuous variable is on the x dimension, the categorical variable is on the y dimension. At the intersection of two categorical variables like study and gender, you get a box plot which is split into different panels, one for each level of the y-axis variable. So you can see the distribution of gender by study. So study 1 would be the first panel, study 2 would be the second panel, and so on. Vice versa, if you have a continuous variable on the x dimension and a categorical variable on the y dimension, you get a box plot. On the upper triangle of the matrix, you typically get a mirror of the plot showing on the other in the lower triangle. The only difference is for the opposite of the scatter plot. Instead of a scatter plot, you can see a small text, a small amount of text. which summarize the result of a linear regression. So the R value, the Pearson correlation coefficient is shown, and the p-value of the linear regression is shown. So why did we get 1, 2, 3, 4, 5, 6 variables in our dataset? If we look at the variable definition panel for the global profile, the covariables panel contains a single row which is set to all covariables under the variable column. When this field is set to all covariable, whether it is the global profile or any custom profile, KIWI will query the database and find the information that was defined under the configure variable categorization menu. This menu lists all the variables present in the dataset, and variables that are identified with the CO category or the CA category, so CO for continuous and CA for categorical, all those variables would be included in the list of variables that will be displayed in the matrix of plots. We have created a separate tutorial video on the use of this particular window. I invite you to watch this tutorial to learn how you can use the functionality of this window. Coming back to the way you can control the list of variables, you can provide a list of a custom list of covariables in this panel. This is what I've done in this first custom profile. In this case, the square matrix only include 4 variables: age, creatinine clearance, gender, and weight. So in that case, I set the content of the covariables panel to include 4 rows, one for age, one for CRCL, one for SEXF, and one for WTKG, so the weight. 3 of those variables were set to continuous variables, and 1 was set to categorical variables. So by setting this field to false, you're implying that it is not continuous and therefore that it is categorical. Labels have been set to default, so the information that you see on the axis title comes from the configure variable labels and unit library. We have a separate tutorial describing the functionality of this library. I invite you also to watch that video to learn more about how you can customize labels and units, how you can add variables, and so on. If you provide a label here, custom label for any of these rows, it would be displayed in the title in place of any information that would be contained in this default library. Now I would like to illustrate the use of some display options. The first thing that you can do is scale a little bit the text size, and the way you do that is by going to the layout panel, and no, I want to view, and you can set a scaling factor in this first field. In this case I use 1.5 instead of the default 1, and that increased the size of the text. It also thickened the symbols and the lines overall. You can also control the spacing between panels. So if you end up with a lot of panels, you can shrink or increase, in contrast, increase the spacing if you have less panels, so you can do that. Something that you can control also is whether you want to use the name of the variable or the names of the variables instead of their labels if you don't have enough space, which is oftentimes an issue with this type of plot. You can go under the settings or the basic settings and set the last field to false. So the show variable labels, you can set that to false, and in this case the names of the variables would be displayed. The final option that you can control is not so much controlling the display, but how KIWI detect potential correlations between a continuous variable. A default threshold of 0.6 is applied to process the value of this R coefficient. Any values that is greater than this threshold will cause the panel to be shown with a gray background. You can set the threshold to any value between 0 and 1, depending on what is you consider significant threshold for correlated parameters. Before I conclude this presentation, I just want to mention that there is no stratification option available in this type of EDAs, but you can have access to data subset functionality and method of handling the BLQ data or the data below the lower limit of quantification. These two functionalities have been described in separate tutorials, which I invite you to watch. The functionality described in those tutorials are strictly applied for pairwise plot metrics. Thank you very much.